Dividing rational numbers. Continuing chapter 2, section 4. Again, you need to know what a rational number is. A rational number is any number that can be written as a fraction. 4 is a rational number because it can be written as 4 over 1. 1/2 can be written as a fraction because it's already a fraction, and so forth. So we're going to be dividing numbers like these today. Dividing rational numbers. Basically, there's just the trick that you just have to know. I'm just going to show you it right now. It's called keep, change, flip. Keep, change, flip. All you have to do is keep the first fraction. So in this example 1 here, keep the first fraction, change the sign from division to multiplication, and then flip the back fraction. Use what we call the reciprocal of the back fraction. So some people will say when you're dividing fractions, you're really, and then you would say multiplying by the reciprocal. We're just going to try to remember keep, change, flip. Once you've done this technique, all you have to do is multiply fractions like we learned in the previous video. Straight across the denominator, or straight across the numerators rather, and straight across the denominators. 1 times 4 is 4. 2 times 3 is 6. This can be reduced, since they are both even, to 2/3. So the answer of 1/2 divided by 3/4 is 2/3. In example 2 here, example 2, again, just like when you're multiplying fractions, make sure that any mixed fraction is rewritten as an improper fraction. So this is an example of a mixed fraction. Let's make it improper by making the numerator greater than the denominator. That's what an improper fraction is. So again, the technique to do that is taking the denominator, which is 7, times the front number, giving us 28, and then adding the top numerator, 30, giving us 30/7. And I'm just going to continue our keep, change, flip from there. We keep the first fraction, change it to multiplication, and flip the back fraction, flipping the bottom and the top. Once you've done this, you just multiply straight across, giving us, not 30, giving us 90/7. And then from there, you just reduce the fraction by figuring out how many 7s go into 90, which is 12. And 12 times 7 is 84, so giving us a remainder of 6/7. There is an example. Make sure you check to make there's no like negatives being multiplied or divided here. Otherwise, you'd have to change your answer, but there you go. 4 2/7 divided by 1/3 is 12 6/7. Now there are some shortcuts, some tricks. Just like multiplication, you can divide across the tops and across the bottoms, but it's only in very, very specific cases where this is true. So in this specific one, 6/9 divided by 2/3, you can divide across the top and across the bottom. That is an okay technique. It just so happens it doesn't happen very often that you're able to do that. So I'm going to show you, if you ever do come across something like this, just go ahead and do this. 6 divided by 2 is 3, and 9 divided by 3 is 3, giving us 1. Very, very simple. Don't have to keep, change, flip. Basically, that's it. Same with this. So 15/16 divided by 10/24, you may think there's no shortcut here. Well, if you look closer, you can actually cross-simplify division problems as well. So cross-simplifying here, 15 and 24 both have 3's in them, reducing that to 5 and this to an 8. Looking at the 10 and the 16, those also have a 2 in common, giving us 5 and an 8 over here. So if you look a little closer, we have the fraction 5/8 divided by 5/8, giving us 5 divided by 5 is 1, and 8 divided by 8 is 1, giving us the nice answer of 1. Much, much easier than trying to take 15/16 times 24/10. That would take you a little bit longer, so try to look for some cross-simplifying tips and tricks before you go and try to do some nasty multiplication like this. And lastly, we've got long division of decimals. Okay, now when you're long dividing decimals, the front number, which in this case is 3 36/100ths, that always goes inside the inside the division bracket. So we have 3 36/100ths is being divided by 0.8, 8/10. Now before you can divide, you need to make sure this front number here has no decimals. There are no decimals allowed outside right there. Well, we have a decimal there, so what do? What you need to do is take the decimal and slide it over, okay, giving us 8. All you need to do is count then how many times did you slide the decimal over. In that scenario, we only slid it once. So you go inside and slide that over 1 as well, bringing that up to here, making our inside number now 33.6. Once you have that number, you can divide or long divide the same as you would. How many 8s go into 3? Not big enough. How many 8s go into 33? I'm pretty sure 4 goes in there, or 8 goes in there 4 times. And then you multiply around. What is 8 times 4? 32. Subtract, bring down the next digit. How many 8s go into 16? 2, and there's your answer. 3 36/100ths divided by 8/10 is 4.2. Let's do one more example of that. You have 65/100ths divided by 5/100ths. Again, the front number is the number that goes on the inside, 0 65/100ths, divided by 5/100ths. Again, that outside number cannot have a decimal, so we need to move it over. In this scenario, we move it over to the right 1, 2 spots, making it 5. So that means we need to take this decimal and move it over 2 spots as well, making our inside number now 65 instead. So you just go and divide or long divide regular. How many 5s go into 6? 1. Multiply it around. Subtract. Bring down the next digit to be divided. How many 5s go into 15? 3. Multiply it around. Subtract. No remainder. Well, there you have it. The answer is 13. So those are your 2 methods, or those are your 2 things you need to know when dividing rational numbers. That is Chapter 2, Section 4 continued. Good luck.